All right, I'm on lesson 4.3. This is page 223, so page 223. Now, we're talking about equivalent ratios and multiplication tables. Now, I'm going to focus on this piece here, equivalent ratios. Some of you that use multiplication tables, if you would still like to use a multiplication table to help you with this, that's fine. But I really think we'll move past that pretty quickly. So I just really want you to have a big understanding of equivalent ratios and how they're very similar to equivalent fractions. So I'm not going to focus a lot on the whole multiplication table on this lesson. You'll be seeing me just thinking of it other ways and explaining it other ways. But I will show you this part in case that helps. So, essential question, how can you use a multiplication table to find equivalent ratios? The table below shows two rows from the multiplication table, the row for the 1 and the row for 6. All right, so what they're saying is they highlighted the row here for 1 and the row for 6. The ratios shown in each column of the table are equivalent to the original ratio. Ratios that name the same comparison are equivalent ratios. So again, I really want you to think of equivalent ratios are very similar to equivalent fractions in that whatever you do the top, you have to do the bottom, all right? So they are similar. They're not exactly the same. But basically, so here they're going to talk about bags and apples. So for one bag has 6 apples in it, all right? And so they're using the 2 blue ones here. So if I go to 2 bags over here, it would have 12 apples. And if I go to 3 bags, I would have 18 apples. So they're just using our multiplication chart of multiplying by 6. 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. All right, so that's all there. And then they show that both ways here. Again, the blue here, if I can zoom in a little closer, they're showing that multiplication of whatever you do the top, you have to do the bottom. Multiply by 3, multiply by 3. Multiply by 4, multiply by 4. All right, so there's really not any big new ideas here. You've done a lot of this. It's just kind of applying it in a different way. All right, so let's take a look at an example here. I will use it with a multiplication chart, but I'll talk about it also a little differently. So the ratio of adults to students on a field trip is 3 to 8. Now, again, I label right away. And I'm just going to write it a little bigger. So I'm going to write my 3 to 8 bigger so you can see it. Now, 3, order matters. So the ratio of adults, so top one was adults, to students. Bottom is students. All right, I need to do that to get my head straight. You know I'm a visual person, so I like to see those labels right there. So they want us to come up with 2 ratios that are equivalent to 3/8. All right. So we can use a multiplication table, shade the rows that show the original ratio. So that's the 3 and the 8 is what they shaded in the blue, all right? And so the original ratio is 3 to 8. Shade in the row for the 3s and the row for the 8s on the table is what they're saying. And then they want us to circle the column that shows the original. So here's my 3 to 8. And then they want us to circle 2 columns that show equivalent ratios. So they circled one here for you, the 6 to 16. So the column for 2 here shows that 2 times 3 or 6 adults when there are 2 times 8 or 16 students. Now, here's what, again, what I do, I go 3 to 8 and then times 2. Times 2 gives me 6 to 16, all right? I just don't go through all this. I just tend to think of it like equivalent ratios and I just do the multiplication. All right, and then they also want us to do the column for 3. So we're going to circle it over here. And so 3 times 3 gives me 9, and 3 times 8 gives me 24. But again, I prefer to go 3 to 8 times 3 gives me 9 224. So this is how you'll see me doing it. I won't be pulling out a multiplication chart. If that helps you, fine, but you are allowed to use calculators for this, so you can just do your multiplication with a calculator and not have to rely on the multiplication chart. All right, so what do they want us to do here? So blank and blank. So 6 to 16 and 9 to 24 are equivalent to 3 to 8. All right, on the next page, page 224, big idea up here, kind of important. You can find equivalent ratios by using a table, that's what we've been doing, or by multiplying or dividing by a form of 1. So we're going to take a look at that and what it means. To me, again, remember, whatever you do to the bottom, you do the top. So if you multiply top by 2, you multiply bottom by 2. If you end up dividing, take the top, divide by 2, take the bottom, divide by 2. You're still going to get equivalent fractions, and that's the same as equivalent ratios in this case. So let's talk about the juice. I'm not really going to worry about this table. I'm just going to cover it up for now. So Jessa made fruit punch. Let me see if I can focus a little bit more. By mixing 2 pints of orange juice, I'm going to underline that, 2 pints of orange juice with 5 pints of pineapple juice. To make more punch, she wants to mix orange juice and pineapple juice in that same ratio. So it's like a recipe, right? If you have 1 cup of flour and half a cup of sugar, you need to maintain that. If you want to double a recipe, you need to maintain that same ratio for it to turn out. So write 3 equivalent ratios for 2 to 5. And again, I'm going to put my 2 OJ to 5 pineapple, all right, just to keep my head straight. And then I come down here and I can fill out my table. So OJ doesn't need to be as fancy as this. Pineapple was 5, 2 to 5. So I focus on this part. Multiplied by 2, 2 times 2 is 4, 2 times 5 is 10. 3 times 2 is 6, 3 times 5 is 15. And then 4 times 2 is 8, and 4 times 5 is 20. So each one of these, I'm circling, are equivalent ratios. All right, so if this is a recipe, if I need a whole lot of juice, I have a lot of friends coming over, I'm not going to go 2 to 5, I'm going to go 8 to 20. All right, and this was in pints. So 2 to 5 is equivalent to 4 to 10, 6 to 15, and 8 to 20. All right. And then, so really here is the way that I like to do it. You're just multiplying or dividing by a form of 1. Whatever you do the bottom, you do the top. So let's write it down, because that's the key. I don't know what they keep saying by this form of 1. Doesn't really necessarily make sense to me. But whatever you do to one term, you do to the other. So terms are pieces, the 2 pieces of the ratio. So again, whatever you do to the top, bottom, whatever you do to the bottom, do the same to the top. All right. So if I have, they want me to write 2 equivalent ratios for 6 to 8. So I have 6 to 8. Error alert. Be sure to multiply or divide the numerator and the denominator by the same number. That's the key. It's what I'm saying here, right? So pick a number you want to multiply. We'll keep it easy. So if I have 6 to 8, if I multiply both by 2, I would have 12 to 16 is also equivalent. Oh, I get what they're saying by the form of 1. This is why. What's 2 over 2 equal? 1, right? 3 over 3. All right, so if I multiply 6 times 3 and 8 times 3, I would get 18 over 24. So as long as I am multiplying or dividing by a form of 1, meaning numerator and denominator the same, or whatever you do the bottom, you do the top, or vice versa, that's what they mean by this form of 1. Now, you can also do it with division. You can go down. So just like we can simplify fractions, sometimes my ratios can be simplified. So I need to look at 6 and 8 and figure out what can I divide them both by. You might think 3 at first, but 3 doesn't go into 8. They're both even, so it's going to be a 2. And again, 2 over 2 is a form of 1, and I get 3 over 4. So 6 to 8 is equivalent to 3 to 4. It is equivalent to 12 to 16. It was equivalent to 18 over 24. All of those are equivalent. So trying just a few problems like your homework are going to be. You do not need to use multiplication table, all right? I really just want you to do the form of 1 where you're multiplying or dividing top and bottom by the same. You can use a calculator. So first one, 2 equivalent ratios to 4 to 7. So what would I do? I'm just going to go 4 to 7, and I can go times 2 times 2, and I get 8 over 14. So 8 over 14. And then I could take 4 over 7 times 3 times 3, and I get 12 to 21. Okay? If you know your math facts really well and you're kind of doing this in your head, you know, that's fine when it's relatively simple numbers like this. All right? So same thing here, 3 to 7. So I could just put times 2 times 3. So 3 times 2 is 6, 7 times 2 is 14. 3 times 3 is 9, 7 times 3 is 21. Okay? The ones I think that are tricky for you are more over here. So notice how they have a blank set of boxes on the right and the left, or sorry, left and right, but this guy's in the middle. That's your indication that it can be simplified. So if you look at 2 and 10, you can divide them both by 2, right? So 2 divided by 2 is 1, 10 divided by 2 is 5. Then if I wanted to multiply by 2, 2 times 2 is 4, 10 times 2 is 20. So those would all be equivalent. All right, and our last little part here for 4-3, on the bottom of 225, I want to look at a few of these examples because I'll throw this at you in homework. Determine whether the ratios are equivalent. So they're giving you 2 ratios, and you have to figure out if they are equivalent. So you just have to ask yourself, can you multiply or divide by the same number to go from one to the next? So how do you go from 2 to 8? By multiplying by 4. So if you take 3 and multiply 4, you get 12. That's correct. So yes, they are equivalent. All right. Yeah, these guys can get a little tricky, but actually not, because it depends if you're going up or down. So you'll find out that sometimes you need to simplify all the way down and then come back up to figure out if something's equivalent, and I'll show you that in a bit. But look here. So, you know, 8 doesn't go directly to 6, but if you look at the bottom, 10 and 10. So if these two stayed the same and those two changed, there's no way they can be equivalent, right? So, because it would be 10 times 1 or 10 divided by 1, and that's not what's going on to get from 8 to 6, okay? 16 to 4. So I would be dividing by 4. So then ask yourself, is 60 divided by 4, what does that give you? It does give you 15. So yes, they are equivalent. All right, and over here, 3 doesn't go into 8, but 14 does go into 28, so that would be times 2. And we know that 3 times 2 is 6, which is not the 8, so that is a no, they're not equivalent. So you just got to look and figure out, am I multiplying, dividing, you know, if one goes up from here to here and the other one to go down, you know that they're not equivalent, right? They both have to go up or they both have to go down. All right, and we'll see you in a bit for lesson 4.